Welcome, everybody. It's nice to see people joining in for this webinar, and people are checking in right now. So we are really, really happy for that you have time to attend our webinar for this day. We are happy to announce that David Burns will present you about mission critical commissioning. It's about how to deliver robust and resilient data centers. And we're really happy to see that David Burns has prepared a very interesting talk about what are commissioning about and why is it interesting to do commissioning when we talk about building and developing data centers in Europe. And we have a team that will talk about, we are a team of 3 institutions, and we have the team of people who will introduce to the SETSA project. And I will say that we have a team of Katrine Solhal from Mercantech, which also is a partner in the project here. And we also have Mr. Conor Lawler from ATU Sligo in Ireland. And me, myself, I'm Lars Boyne. I'm from UCL University College in Denmark. And we are also part of the project. And maybe, Katrine, you will tell short about what are your role in the SETSA project.
Yes, of course. Thank you, Lars. So my role is that I have the work package called dissemination, which means that my role is to make awareness of the project. So we would like people to know as much as possible about the data centers and how it works, as David Burns also will share a bit about. But also, how could young people or people in general see a career in a data center? So this is Mercantech's role in the project. So to make awareness and promote the projects. Yeah.
Yeah, thank you, Catherine. It's a very vital role you have because, the problem from the data center industry these days is that nobody of the students know the data center industry very well. So you are really doing a very important job, Catherine, with the dissemination and also the communication about all the possibilities which you can find as a student in the data center industry in Europe. And then I'll shortly present what we are doing from UCL in the project. We are working with developing a curriculum, and part of that work is also to develop webinars like this one, and also to do exchanges for students. So you guys can travel around Europe and meet other students and then solve some challenges from the data center industry. We have a part of the SETSA project is also that we are an IT university college, so we have also a focus on IT competences like Mercantech. You also have data technician as a educational program, and we also have programs in the software development area and also in the cybersecurity bachelor programs. Then I will give the word to Mr. Conor Lawler from Atlantic University. Conor.
Thank you, Lars. It's Atlantic Technological University, based in the west of Ireland in Sligo, northwest of Ireland, and we're a partner in this project as well. We run actually, Lars, I don't have control of the slide deck. It says presenter has turned off participant navigation. So maybe you'll just move on to the next slide for me there, please, and see if you can work that out. Okay. So this shows you where we are located in Europe, and the 6 there's 6 countries involved, and you can see on the map there, Finland, Denmark, Belgium, the Netherlands, Ireland, and Portugal. Portugal's been kind of pushed off the side there a little bit, but yeah, so a very exciting project. And next slide, please. We're involved in this project because we have a BEng in data center facilities engineering. Now, we developed this with Google about 8 years ago. It's online, so most of the participants are working in industry at the moment. Generally, they're qualified electricians who've worked in the industry for a couple of years, and then they're looking to upskill. So, and it's a very effective move for them within the industry. This course is available to anybody who qualifies for it. So in Europe, you would talk about level 5. In Ireland, we call it level 7. Unfortunately, we're on a different scheme. But basically, if you're a qualified electrician, if you are moved up the educational ladder, you can qualify for this as long as you have a qualification in the correct area. And the next slide, please. So the challenge then, from our point of view, when we talk about the challenge, this is the challenge for CEDSA. And so next slide, I think. Yeah. So we find that in Ireland now, there's an awful lot of negative view of the data center industry, because people say, oh, they're using all the energy, blah, blah, blah. And they organized protests outside the data center exhibition 2 years ago, and they organized those protests on WhatsApp and Facebook. A lot of people just aren't aware of how data centers serve the community and serve the country. And they're very, very integral part of nearly everything that we do. Very, very important, but also not a negative thing at all. We use a lot of energy in data centers, but we use a lot of energy to build cars. We use a lot of energy to run hospitals. There's nothing wrong with using energy necessarily. And data centers, if we went into it, actually can save a lot of energy too. So it can be part of our sustainable plan. But back to the slide, critical digital infrastructure. So obviously, everything, a lot of places that use data centers, whether it's the hospitals for medical records, industry, business, it's critical. And along with the whole social media side of things and entertainment. So very, very important part of economy and life. Engineering complexity. So very, very complex. We'll have a quick look at the complexity of data centers themselves. But there's a lot of, it's a very fast-moving industry, so technologies are changing all the time, not just the IT technology, but the cooling technology, the power delivery. There's lots of changes all the time, so it's quite exciting from that point of view. And a huge global economic impact, which we've talked about already. So next slide, please. So the challenge is to deliver 24/7, 365 days a year, power and efficiency. Cooling is an important part as well. So to keep the data center up and running, what people don't realize, if the data center room itself overheats, if it overheats, then the data center will shut down. So there's quite a lot of pressure, and it's as we said already, critical. So and there's also obviously an energy efficiency challenge. 99% of the energy that goes into the computers on the data center are given off as heat, believe it or not. A huge amount of heat is generated by data centers. So we need to efficiently run the data centers to generate as little heat as possible, and then also to reuse that heat. Another important challenge within the data center. We talk about power usage effectiveness. That's basically how much energy you put in and what return you get out of your data center. And the lower that is, the better. But it's the key measurement when you take a data center to see how much energy you're putting in and what you're getting out of it. And then sustainability, especially nowadays, is a huge task for data center managers and workers to, as we say, keep it clean, keep it efficient, and keep the cost down. Next slide, please. So the solution, I have to give it a second for those videos. Lars created this presentation. I think he did an excellent job. So as part of the solution, well, CEDSA are developing universal curricula for all workers within data centers, so that will improve mobility of workers within the industry. So if you're working in one place and you say, well, these are the qualifications I have, then everybody in the industry knows exactly what you can do. And that's really the one of the main tasks of CEDSA. We created our BEng, as I said, a few years ago with Google mainly, but also Microsoft and Apple and Facebook. And it's all what our task really was to train more electricians from mainly the domestic field so that they could work within data centers. And we've graduated over 200 people in the last few years. It's been very effective and successful. It's a flexible online curriculum, so it's every 2 years. Students study online 2 evenings a week. And part of that is that they go to Hella in Belgium for a week each year to do practical labs. We're also looking at, and I believe as well with ACAMI, which is one of the sister colleges here. So ACAMI will get their cohort of Finnish students who will study online with us, but do their labs in Finland. And we're looking at spreading that model out further to colleges in Portugal and possibly France and further afield in the next year. So if you're from a college and you're interested in that, please get in touch. Next slide, please. So the 3 pillars of data center mastery we have within our course, we focus on 3 main areas: mechanical principles, power and energy engineering, and controls and SCADA. So the mechanical side is really all about cooling the data center. And one smaller element of that actually is water treatment, which you may not be aware of. But water treatment, what happened to the slide? Water treatment, because we use water to cool, so that water has to be treated so that we don't have, you need as clean a water as possible to cool the data center. This video is putting me off, Lars. Can you click again, please? The power, okay, so the importance of cooling is vital for data center uptime. I mentioned that already. So you learn about thermodynamics fundamentals. It's important that people understand how heat travels. If you're working in a data center, say as an electrician or a networking networker, one of the problems in the old days was that there's a lot of cables and people let cables block airflow. So the cooling air that was going through a rack was getting blocked by wires. So everybody needs to understand every element of the data center. So the networking guys back then, they weren't aware of the cooling, of the job of the air to cool the racks, you know, so that often led to problems. It was a common issue. My point being that you need an all-round education in the data center to do your own job, even though you won't be dealing with every element of the data center. So within the cooling, we look at thermodynamics, environmental sustainability, again, which is very important. We mentioned that already, and system design skills. So we show how data center rooms are built. You may never actually design a data room, but you have to understand when you go in why it is the way it is. It helps, again, in the efficiency of your job. Next slide, please. So the power side of things, again, a lot of power goes into the data center and most of it comes out as heat, but the power has to go in. And with AI now, there's a big issue because AI has a huge, can lead to a huge increase in the concentration of power within a data room. So that's a major issue. There's the stability of that power. There's the problem of if there's a shutdown in one area, that we have to get our generators up and running so that there's no drop in performance within the data center. So our UPS systems, uninterruptible power supply. There's energy management standards and electricity flow to server chips. So there's a lot of different aspects there too. And if you are going into work in the data center and haven't worked with electricity and power before, you get a very good grounding on that within this degree. Next slide, please. So control and automation, so SCADA, a lot of this is to do with controlling airflow, measuring data as well, like humidity and heat. So the whole system has to be integrated so that it is kept up and running. A lot of different aspects to it. So the SCADA systems monitor and control facility operations and provide real-time data for efficient management. Then there's network protocols and automation and operational excellence. So next slide, please. Yeah, so as I mentioned already, we have our labs. We run them at the moment, we run them in Hella in Belgium. So we have students from all over Europe who learn online and then go to Belgium. Most of them are based in Ireland, but we have had students from as far away as Texas and Abu Dhabi. So yeah, and there's no reason why we can't facilitate people globally. The only issue, obviously, is that you have to go to your labs in Hella. And as I said, we're looking at spreading that out so we can do the labs in Finland and hopefully further afield over the next few years. Next slide, please. So the future. Next slide. Okay, so yeah, so career trajectory. So as I said, a lot of people, most of the people coming in are coming in as qualified and experienced electrical technicians, but there's a lot of scope for movement. And I would say as well, it's our aim through CEDSA to provide career trajectory to all different people working in all the different areas within the data center industry. And over the next couple of years, we have two and a half years left to complete our curricula and get our industry recognition. Yeah, and we can see this. I think within the EU, it's seen as a very, very important element to get the data center industry up to speed with mobility and the right type of training for people coming into the industry at the moment. It can be quite haphazard, I think, for some of the main players to find people. Okay, next slide, Lars, please. So yes, if you're interested in this particular course, you'll find the information on the website atu.ie. And our focus on technical excellence, industry relevance, and European collaboration, very important. As I said, we can talk to a number of our previous graduates, and I can't say all of them have got promotions, but I know of a number that have got significant promotions on the back of their learning within this course. So it can be very significant for you on your career path. Next slide, please. And that's that presentation. So Lars, you want to introduce David there?
Yeah, thank you very much, Connor, for the thorough introduction to your programs at ATU and the possibilities for targeted educational programs. Now I'm very happy to present you for David Burns, who will talk about mission critical commissioning. Here we go, David.
Thank you very much, Lars. Much appreciated. And as an ex-student of Conor Lawler's at ATU, I can absolutely promote and confirm that, you know, the excellent courses that ATU and indeed Connor runs and has run in the past are give good paths to in your career, right? So I again thank you for the opportunity. I'm delighted to be here for myself personally and to represent my company, Bureau Veritas Primary Integration, or BVPI for short. So we'll keep it nice and short and sweet, and it'll be BVPI for the rest of the call. But again, look, thanks to everybody for jumping on. Again, delighted to be here. I want to talk just a little bit about our company and in particular the whole area of commissioning within the mission critical industry, as we call it, and certainly data centers are very much at the precipice and at the top of that list of mission critical facilities that we work with. It's important. I'll just start sharing my screen, but it's important to it's important to just frame what Connor and Lars have said. The data center space is an absolutely huge area globally. There's, you know, we all work, we all play, we all sit, you know, we all sit down in the evening watching our Netflix or Disney Plus or whatever else. You know, we're on our devices looking at Facebook and other social media and all the rest of it. You know, we get paid electronically. We pay electronically for a lot of our things that we procure and purchase as we go through life. All those transactions, all those sharing of family events on social media, whatever, is all data centers. You know, you hear people mention the cloud and whatever else. They are data centers. They're hard infrastructure. They're buildings. They're hard, tangible buildings, and they're sophisticated buildings, and there's a lot of technology and equipment and systems in there to make sure that the internet stays alive and all the other good things that we have in our lives stay alive. Okay. One of the sorry, I'll just share my screen again. That's the second time I said it. So just bear with me for a moment. Sorry, guys. Technical. So. Sorry, guys. My fault. Can you see that?
Yeah, that's good, Dave.
Yes, my apologies. I'm having trouble with this all day. I think we're good. I'll keep going. So Bureau Veritas primary integration, right? So as I said, we work in the mission critical space, which I suppose at the top of that list of mission critical sits the data centers globally. So our mission as a company, as a commissioning company or a commissioning agent, is to be our client's trusted global technical partner. And we do that through supporting their mission critical facilities through exceptional levels of service and quality. So that, you know, what we sell is expertise. You know, BVPI doesn't sell any products. We don't sell machines. We don't produce anything for the data center space apart from selling expertise or SMEs, subject matter experts, to our clients. Okay. So Where does BVPI operate? We're a truly global company. It was a company that was started in the US back in 2005, and since then it has expanded right across the globe, and we're operating literally right across the globe. I'm talking to you from our Dublin head office, which is basically we run the operations for Europe, Middle East, Africa, and Asia from this office. So like we have a hell of a lot of engineers and staff right across those regions, commissioning sizable data center projects for multiple hyperscale and what we call colo clients in the business. Just to give people an idea of the size of BVPI, again, I'm not going to take too long on this one, but you know, our clients are 5 out of the top 10 global hyperscalers. So hyperscalers are basically clients who build, you know, megawatt, multi-megawatt data centers in the one sort of building or the one campus. And we, you know, globally, we commission those facilities for those types of clients. 10 of the top 20 global DC providers. We have 15 plus Fortune 100 companies who we can talk to as clients. 40 plus Fortune in the Fortune 500 list. 10 top financial companies, and we have a number of federal agencies that we do work for in the US primarily. We've been in the business for 19 years or more. We have over 400 full-time employees across 40 countries currently. We've commissioned over 10 gigawatt of data centers across the globe to date. We have successfully delivered for our clients over 2,000 projects across the business, and that accounts for over 12 million square feet of data center buildings. Okay, so our business is a big business in this space. Okay. So again, what do we specialize in? So commissioning, QA/QC, quality assurance, quality control, and we also support operations of existing mission critical buildings, including data centers. So QA/QC and commissioning sort of work hand in hand. I'll show you shortly, but QA/QC, we carry out a lot of QA/QC, and we have a lot of QA/QC experts who make sure that the quality of the equipment and that the equipment of the vendor that's been supplied by the various vendors to the data center builders and data center owners are as per the project requirements. Just to break down just of the suite of services that we offer. So there's 5 main sectors: planning and design, procurement, construction, quality management and construction commissioning, and indeed operations. So we do everything from design reviews are a very big part of what we do in the commissioning process. Commissioning specification development is another item that we do a lot of that for not all clients, but quite a few who need support with developing their own commissioning specifications as to what they want and what the minimum requirements are for their projects across their business. Again, we do QA/QC, so integrator and equipment vendor shop inspections, factory acceptance and factory witness tests are very common in what we do. Again, it's to ensure that the equipment that's been manufactured by the manufacturers, so it could be anything from diesel generators to uninterruptible power supplies to static transfer switches, all that type of equipment before it's shipped to a project to be installed in a data center, it would be checked at the factory by our team on behalf of the client. We also do QA/QC around MEP systems, mechanical, electrical, plumbing, security systems. Obviously, security around data centers is quite a huge topic and a very important topic for our clients. So we do a lot of QA/QC checks around those systems as well. Low voltage systems like access control systems, camera systems, stuff like that. And obviously fire and life safety systems are a huge part of the performance of the building, and ensuring that those systems are operating correctly when you need them, that they work. All right, that's what we test and verify as part of that. Level 2, level 3, so level 2 installation verification. So again, as on behalf of the client, we would do a QA/QC checklist to verify that the equipment that's been delivered from the factory is as per the specification, that it is, that there's no damage on it, that it's been installed in the correct position, and has all the components it's meant to have. On leaving the factory. We also carry out startup verification. So once the vendor has installed the equipment and all the associated, so if we take air movement equipment like air handling units or stuff like that mechanically, that the air handler unit will be put into its final position in the building, and other contractors or a general contractor would have air ducts connected to the air handler unit. All the electrical connections would be made to give it power. All the I&C or instrumentation and control wiring would be installed, and point-to-point checks done at that stage. Functional performance testing at level 4, that's really bread and butter stuff for us, and that's where our commissioning engineers work on the ground. And they perform pre-described tests to prove that the equipment is programmed properly, that it operates properly, and that any fail-safe or fail-over scenarios work correctly and as per design, and that type of stuff. Excuse me. We also do, importantly, integrated system tests, or at level 5, which are I'll talk a little bit more about that now just in a moment. And then from an operations point of view, we do, this is after commissioning. This is where the owner has received control of the building and they're operating their data center. We also do support them in carrying out different types of audits and different types of training of the operations staff and stuff like that. Okay. So a commissioning agent. So we're talking about commissioning. So what is commissioning? So ASHRAE defines commissioning as a quality focused process for ensuring that a building systems are designed, installed, tested, and operated to meet the owner's project requirements. So basically, it's a systematic process of verifying and documenting that the building and its associated systems are designed, installed, and tested, that they conform to meet the design intent of the owner. Okay, so that's the ASHRAE definition of commissioning. So what do we do in practicality? What do our commissioning engineers do? So in this picture, it's just some of our actual commissioning engineers working, our commissioning agents working on an actual project a few years ago on a project in Sweden. So that day-to-day sort of stuff. What do we do? So develop commissioning plans. So commissioning doesn't just happen. It's a very thorough, thought out and planned set of events, and a sequence set of events that the commissioning can happen in a planned manner, and that you're not, it allows for coordination between the different disciplines, and ensures that the right people are doing the right things at the right times as part of the commissioning process. verify system performance. So, and I'll talk a little bit this more in a little bit more detail in a moment. But ensures all the mechanical, electrical, control systems are performing as per the design intent. And also, Conor mentioned it earlier on, the other important verifications that we would do as part of efficiency is check and verify the PUE, or power utilization efficiency, and also water utilization efficiency. Again, data centers want to, data center owners, designers want to maintain maximum uptime, but they also want to do it, operate their data centers in the most efficient manner possible, I should say. What else do we do? Manage documentation. So reviewing design drawings, reviewing equipment submittals, and operation manuals to confirm alignment with the owner's project requirements, and indeed the commissioning scope of the project. Coordinate stakeholders. So again, work with the general contractor. So the general contractor is de facto the main building contractor. So when a client wants to build a new data center, they'll award a contract to a general contractor who'll take over the full build, construct life cycle of the building to basically hand over the keys to the owner when it's finished. Functional testing, again, as a commissioning agent, you direct and witness the startup, load testing, failover testing, and importantly the sequence of operation, verification of all the critical equipment and systems within the building, such as on-site power generation, again, diesel or gas-fired generators, UPSs, so uninterruptible power supplies, and battery storage systems are a critical part of the power lineup of a data center. Data hall and server cooling and room pressurization, and the checking and verifying the integration of the BMS and EPMS, so emergency power management systems as well. Okay. Tracking issues. So as commissioning agents, we would create a number of issues as we test the equipment or test the systems. If we find that things aren't operating as per design or aren't operating as per the client's base of design or by the sequence of operation documentation, we will raise up issues and make sure that the correct vendors and that the general contractor, wherever else, are made aware of those issues and fix those issues until they're resolved. And if we need to retest the equipment to verify that those issues have been resolved, well then that's what we do, and that's where we as commissioning agents take that lead and take that charge. And again, it's all about delivering quality and making sure that the client is getting the best bang for their buck. Okay. Again, validates redundancy and reliability. So Conor mentioned earlier around uptime. So most of the data centers are built to the Uptime Institute's tier categorization for redundancy and for fault tolerance and that type of stuff. Supports turnover and training. So when the commissioning is coming to an end and we've successfully delivered a building with the GCs and the vendors in the team, and we're handing over the building to the final owner and final operators. As a commissioning agent, we would also help with training and training materials to how best operate the data center and deal with emergency situations and that type of thing. Just around full life cycle commissioning, again, I've sort of gone through this in fair bit of detail, but again, this slide gives a pictorial description, I suppose, of the different levels of commissioning. And I've gone through this in fairly decent detail, I hope. But again, for anybody that wants the slides and wants to look at this, that this pictorial gives a good sort of representation of the life cycle of the commissioning. Okay. Just around level 5 and ISTs. So the level 5 or IST or an integrated system test for a commissioning agent or a commissioning company, and for a data center construction and commissioning life cycle. Like the IST is really the penultimate set of tests, and basically a shakedown of a new data center building. And basically the integrated system test is a set of pre-described tests to introduce significant failures and simulate power utility failures, major equipment failures and equipment losses, or even system failures. And the idea behind that is to prove and ensure that the automation and the control systems identify and can start up other parts of the data center, and that you can start up, that it automatically starts up generators, that the UPS system and the battery storage maintains power to the servers while there is an outage. And again, it's to maintain that fault tolerance and maintain that maximum amount of uptime. The last thing any data center operator or owner wants is any sort of an outage or a downtime on their data center. Again, the amount of touch points with business and commercial entities and indeed with the public, like I said at the top, anything to do with social media or banking or anything else, air traffic control, stuff like that, is all affected by a data center or data centers going down, basically, or losing power, or not, or whatever else. So it's critically important, and that's where commissioning agents come into the fray. All right. Again, just around sequencing of commissioning, where does it sit? So we have the level 0. Here. So we have our level 0 here, and then one. The commissioning levels all the way up to level 5, which is basically the IST. So that level 5 here. So level 0, again, design reviews. So from a commissioning deliverables, what does that mean? So reviewing designs, reviewing the sequence of operations documents, reviewing basis of design, specification, general specifications, commissioning specifications, equipment specifications, that type of thing, and also reviewing equipment lists. And as a commissioning agent, when we're doing those reviews, we review them and document those reviews, and any findings that we have, we'll document them and bring them back to the client for review. All right. Level 1, again, submittal reviews is a big part of what we do, but also factory witness tests is a big part of what we do. So again, our engineers, our commissioning agents will attend the vendor or the equipment vendors' factories. Again, whether it's a UPS manufacturer or a generator manufacturer or a chiller manufacturer on the mechanical side, our commissioning agent will go on behalf of the client to make sure that the testing that the factory is going to do on that equipment to prove that it meets design, that those tests are actually done, that they're done correctly, and to make sure that the factory is using proper calibrated test equipment and metering equipment to verify performance of the equipment. So FWTs are a very important part of what we do. At level 2, we have the pre-startup tests. So basically, you're doing QA/QC checks and verifying that the equipment is not it is what it's meant to be. It is coming with all the options, all the equipment and extra equipment that might have been specified for that particular project, that it has come shipped with that. There's no damage and that type of stuff. Level 3, equipment startup. So again, this sits under construction. The responsible party is the general contractor and the equipment vendors to make sure that they're starting up their equipment, they're getting power, they're doing their point-to-point checks for the instrumentation and controls and the BMS and SCADA system. And in most cases, our client will ask us to go and witness, if not all of those tests. We'll certainly test what we call the first of kind. And again, is to make sure that the vendor and the GC are delivering the equipment ready for level 4 or functional performance testing here. So level 4 functional performance testing, that's again really where we are really important to the project. That's where we take our test scripts based on the sequence of operations documents, and we will test each piece of equipment to make sure that it operates as per design and that it performs as per design. If it doesn't, we raise issues. We push those issues back to the vendor and the general contractor to say, look, this isn't, this piece of equipment isn't doing what it's meant to do as per the basic design or the sequence of operation, and it needs to be rectified and possibly retested based on the severity of the issue. Okay. Once all the equipment and the systems have been commissioned to level 4 and have been signed off, and all the equipment is ready to go, we then go to the DIST stage at level 5. And again, like I said, it's a full hands-off, full shakedown of the building and the electrical and mechanical cooling systems and whatever else within the building. And once and only once the DIST has been passed, and we as the commissioning agent approve it and say, yeah, look, it has, the building has performed as per design, well, then we'll accept the building or the data center on behalf of the client, and basically then it moves on to hand it over to the operations team to operate the data center fault free, we hope. All right. So from a mechanical point of view, what types of systems? So fuel oil distribution, that's mainly for the backup generators. Process water systems, so a lot of water treatment systems for process water for maybe adiabatic cooling systems and stuff like that. So they're normally quite sizable systems. Room HVAC systems, fire alarm and firefighting system verification, and cause and effect testing. Testing of air movement equipment like air handler units, make-up air handler units, fan systems, stuff like that. Data hall room pressure control, temperature and humidity control is a massive part of what we do mechanically. These data halls operate quite tight temperature and in particular relative humidity set points and specification, and they're normally quite tight on the plus and minus from the design value that they're allowed to operate within, I should say. Liquid cooling systems are becoming very more prevalent now in the data center space, particularly with AI. The amount of kilowatt density per server rack within a data center now is becoming quite large, and liquid cooling is the more what would I say, the air cooled is not going to cut it anymore, and therefore the newer designs are using liquid cooling systems, which are radically different, I suppose, to air cooled data halls. So you're dealing with cooling distribution units, heat removal and recovery systems, on chip and rear door heat exchangers and stuff like that. Okay. chill water production and distribution systems, so chillers, your traditional type of cooling and chilling systems. Extract fans for pressure balance, room pressure balancing and smoke and evacuation and extraction, and building management system integration and verification. That's a huge part of what we do as well. Okay. Electrically, on-site substations, they can be quite large systems and important systems on particularly on hyperscale projects. AC and DC, so alternating current, direct current power systems, power string commissioning. So basically all the equipment on the power string from where the utility power connects to the substation all the way through to the plug on the back of the server. We need to verify and ensure that all the N+1 redundancy and resilience is tested and proven to work. And again, it's to prove that the servers are not interrupted if there's any big outages either on power or plant or equipment failures within the data center. So that's pretty much around the electrical control systems. Again, like I said, none of this equipment or none of these buildings can work or operate without very sophisticated control systems with very sophisticated control philosophies and control sequences. As a commissioning agent, as a commissioning company, we have to verify and prove that all of the control systems and the SCADA and the BMS works correctly and as per design. And as you can probably imagine, within a control room for an operations team and an operating data center, there's a lot of screens, there's a lot of graphics, there's a lot of information that they get and need as regards how the data center is operating. So our job as commissioning agent is to prove and verify that all the graphics are correct, all the buttons and switches and knobs and adjustments from the BMS are, when an operator changes a set point, that is the correct set point that's been changed. We verify all that during level 3 and certainly at level 4. Okay. So just before I jump on to the graduate program, one thing that's very important, I've sort of broken this out into sort of 3 distinct views, so mechanical, electrical, and controls. But for commissioning agents and for the people on this call, it's important to realize and know that it's really important that you have a good general knowledge of all those systems. And I think as a commissioning engineer myself and working for a commissioning agent company for a large number of years, the variance and the knowledge that you can gather and gain working on these buildings and these designs is a huge advantage. And there's no, I was going to say there's no 2 days the same. There's probably no 2 hours the same when you're commissioning these sophisticated systems. And the learning and what you can learn from other experts that you'll be working alongside in the commissioning teams is invaluable. And I think it makes working as a for a young person or a young graduate or a recent graduate coming into an industry and looking for something exciting and something different and something where you're going to gain a hell of a lot of knowledge about various types of systems and disciplines. This job and this role is hugely attractive. And if you're coming from any of those disciplines, and I'll talk about disciplines now in a second, well then, I would definitely recommend certainly looking at it. And if you're interested in looking at it, we'd be absolutely delighted to talk with you in a bit more detail about what we're about and what we're offering. Okay,
David. Sorry, David. Yeah, we've only got a few minutes left, and I think that last point you made was one that I was going to ask you about.
Yeah.
So for students, if you want to get into this business, if you can start with commissioning, then you'll get a great overview of all the different aspects of the data center, and it gives you a fantastic fundamental learning really of the whole thing, so it really prepare you for a great career in the industry. I wonder if you'd let us know about the sorry for rushing you, but people have to get on. So I wonder if you could let us know about the graduate programs, and then maybe we'll throw it open for a couple of minutes for questions. Is that okay?
Yeah, sure. No, that's no problem at all. So look, we have worked on and have developed a very comprehensive graduate program within the business. We have within our company, we've invested a lot of money and resources into an in-house university. We call it BVPIU or BVPI University, which is basically it's built on Moodle, but it's basically, it is what it says in the tin. It is an online university. We have a lot of technical CBT training on that platform, which is available to anybody that joins the business. We also have a dedicated graduate program course that's built onto that platform, and basically when somebody joins us as a graduate, they're not, you're not just thrown out into the field to be ate by the wolves. Absolutely not. We have a very comprehensive in classroom course and courses that we give. They're led by our senior engineers and some senior trainers that we have in the business. And in practicality, if you were to come and join us in BVPIU or BVPI, I should say, you would be for a number of weeks in the head office here or wherever, and there would be a comprehensive set of trainings given to you in a classroom-led environment. That's then sort of moves on to you're sort of given a buddy or assigned a buddy within the business. Again, it will be a senior person within our commissioning team, commissioning group, and we would identify some projects where you could actually go and get boots on the ground and get first-hand experience of working on live projects where our teams are commissioning for a client, and we track and trace and through learning plans, we start working through the different competencies that are needed to be a commissioning agent, whether it's electrically biased or mechanically biased. There's a learning path for you, the other, like I said, you work with a world-class engineering team. You're working in cutting-edge data center designs and technology projects. We offer significant amount of travel if you're willing to travel. We proactively look for our people to travel around the business, around the globe. If you want to work in Europe, you work in Europe, and if you want to go further afield, well then we can work with you to get you onto projects around the globe as well. We proactively do that because we want our engineers to work in different client programs, because they get exposure to different designs, different way of doing things, and different types of equipment. And that type of exposure, and we have found and continue to find that helps people to grow into more more specialist and more dedicated engineers, and like it gives you, it's a very specialized field. Being a commissioning agent or commissioning engineer is a very specialist field. It's a very small industry globally, and if you want to look at something that where you could potentially grow very quickly, and become a specialist again, like in a very specialist field, and become known very quickly. I would suggest that this is the job and the career for you.
So David, you'll give us links, and we'll post those links on the website.
Sure.
To your graduate program.
Yeah.
Okay.
Absolutely.
I'm afraid we're out of time. Lars, what do you think?
Yeah, we have time for one question from the audience. If you are having a burning question.
Go ahead.
I'm just curious to know how many graduates do you hire each year, David?
I wouldn't like to limit that. We're a very fast growing company globally, and we have a number of needs across certainly Europe. So we have projects across Spain, Denmark, Frankfurt in Germany, here in Dublin. So I wouldn't like to say, look, we're only hiring 4 or we're hiring 10. Our business needs change all the time. But what I can tell you today is that we're very actively looking for graduates into 2026. And we'll happily take that pipeline of graduates in, and we would have room for them in the business. So do we have a fixed number or budgeted number per year? The answer is no, we don't. Certainly not for.
Okay. In terms of apprenticeship or internships, is that a possibility in your company?
Yeah, no, absolutely. We have historically sort of been focused on graduates and a graduate program. But as I mentioned to Conor earlier on, we are absolutely looking for the trades, and apprentices are absolutely welcome. And if they want to follow the career path into commissioning, we will absolutely talk with them and work with them to get them there. Absolutely. Okay.
Thank you very much, David, and thank you for your thorough introduction and the insights of what is commissioning. We are very happy that you would spend the time with us, and on the behalf of the CITSA team, we thank you very much, and hope that you will find some graduates. And we are also looking forward to a good cooperation in the future with you guys.
Yeah. And same here, Lars. Look, as a company, we're absolutely delighted and thrilled to be involved, and we're not going anywhere. We're in for the long haul.
Yeah. Okay. Yeah, and thank you to Katrina and Conor on the behalf of the CITSA team. Thank you for your presentations, and see you next time. We have a next webinar coming up, December the 15th, and the topic of that will be mission. It will be infrastructure as code. So see you in December. Thank you for now.
Very good. Thanks all.
Bye-bye.
Thank you very much.
Thank you.
Take care.
Thank you. Thanks.
Bye. Bye-bye.